Okay, so I've got a word problem for you. And again, so the next two examples, this one and the next one will be word problems. So you want to make sure that you listen carefully to what I'm reading, because I'm going to write down and I'm going to decipher the information as I read. But you're also going to want to make sure when it comes to word problems that you're doing the same thing, that you're reading carefully and then you're writing down information as it's given to you. So that way, two things. You don't have to go back and reread the problem, okay? And then you have all the information already written down on paper that you can use and what the unknown is, right? And so then you can use what's given to solve for the unknown. Okay. So now, I'm going to read this carefully and write down the information. It says, an industrial firm uses a computer system that processes let me read that again. An industrial firm uses a computer system that processes and prints out its data for an average day in 20 minutes. Okay, so it takes 20 minutes to print out the information. Okay? And that's it for an average day. To process, then it continues. To process the data more rapidly and to handle increased future computer needs, the firm plans to add new components to the system. One set of new components can process the data in 12 minutes without the present system. Okay, so this is the present system. The new system alone, right? So what does that tell me? The new system all by itself can process the information in 12 minutes. Right? Can process and print the information in 12 minutes. Okay? By itself. Okay, so then it continues. It says, how long would it take the new system in combination of the present system and the new components to process the data? So in other words, we know that the present system by itself takes 20 minutes to process and print. The new system by itself, or excuse me, the new component, I should say, by itself, takes 12 minutes to process and print the information. So the question is how long would it take for both of them working together to print the information? That's the question, right? And it says, first, let x equal the number of minutes for the new system to process the data. Okay, so let's write that down. So x equals number of minutes for new system to process and print. Next, we know that it takes the present system 20 minutes to do it. Okay? So, let's think about this. How are we going to combine these? So we've got one print job. Right? This is how long it takes the present system to process the one job. This is how long it takes the new component by itself to process the one job. X is going to be the number of minutes for the new system to process and print the one job, right? The information. So we know that what's the rate then? It takes 20 minutes, right? So that means at a constant rate, the old system prints off at a rate of 1/20th of the job. How do I want to write this? Right? It's 1/20th of the job. Oops. So per minute. So 1/20th of the job per minute, right? And after 20 minutes, the whole job is complete. Whereas the rate of the new component is 1/12. It prints off 1/12 of the job per minute. So these are the rates at which they work, right? So again, let me just re-say that. It takes 20 minutes for the present system to run the job on average. So that means that the rate at which it processes and prints is going to be 1/20th of the job per minute. And then after 20 minutes, right, it equals 1, right? So after 20 minutes, right, 1/20th of the job per minute times 20 minutes equals the whole job, right? And so the same thing here is if we take the rate at which it processes and prints the job, which is 1/12, times the 12 minutes, then that is also going to give us the full job. But now, we want to know, what if they were working together? Well, we know it's going to take X minutes for the entire process with them both working. That's what we have to find out. That's the unknown, right? So that means, but we know these rates, right? So now let's use these rates, and so we know that this is the rate that the present system works. This is the rate at the new component works at. So how much of the job is going to be done? Well, the old processor, the old system is going to do one portion of the job. The other system is going to do the other portion of the job. Well, how do we rate the portion of the job? It's going to be the rate times the total time it will take to do the job. Which in this case is X. And the portion of the job that the new component will do is going to be its rate times X. And so, what does that do? Well, it gives us the equation that we're going to need to do, right? So we've got the rate times X and this rate times X, and we need to add those to get, because this is the portion of the job that the old system will do. This is the proportion of the job that the new system will do. And so we just need to add those together. So, in other words, we get 1/20 times X plus 1/12 times X will equal the entire job. And so now, what do? Well, you have to multiply. So now we've got an equation with fractions. So now if we multiply by the least common divisor, which is what? Well, again, the least common divisor here is going to be, well, 2 times 2 squared times 5 is going to be this one. So this is 2 squared times 5, and this is 3 times 2 squared. And so the least common divisor in this case is going to be 2 squared times 3 times 5, which is going to be so you get 15 times 4, which is 60. Okay, so now if we multiply everything by 60, what do you get? Well, you get 60 divided by 20, which is 3, so you get 3x, right? Plus, and then you get 60 divided by 12, which is going to give you, what, 5x equals 60. And so then 8x equals 60, and then x equals 60 divided by 8. And so what does that give you? If you stick it in your calculator, you get 7.5 minutes. Or you could just do it in your head. So 7.5 minutes. So that's the answer. Okay, so again, the main thing is in order to come up with this equation, you had to be able to read the problem carefully and understand that these are the rates. This is the time, but we can change these times into a rate by dividing by the total job. So one whole job takes 20 minutes. So it's one job per 20 minutes. And the rate of the new component is one job per 12 minutes. So we get 1/12. And so then to take that rate times the amount of time it takes them together for both of them. So this equals the proportion of the job, the portion of the job rather, that the old system, the present system would do, plus the portion of the job that the new component would do, and that has to equal the entire job, which is 1. Okay? And that's it. See you next time.